All right, chemical bonding notes. There's three types of bonds. The first one is alloys, which is metallic bonding. And metallic bonds are composed of two or more metals, and they kind of have the sea of electrons. And that's why they're such good conductors of electricity, because the electrons are free to just kind of roam around in here. And this is what makes them good conductors of heat and electricity. So ionic bonds are the transfer of electrons. And so they have ions. You have cations and anions, and we kind of went over those. Here are some characteristics of ionic bonds that y'all need to know. Now, we've labeled these charges on your periodic table. If you haven't done it, you need to do it right now, because you need to know these charges. So over here, it lost one electron. This whole group lost 2 electrons. This group's lost 3. Depending on where it is, like these usually lose and these usually lose and these usually gain 4. This group gains 3, gains 2, gains 1, and is content for now. Now the transition metals, since they have those, they kind of have those free roaming D block electrons, they can bond with more than just what's in their valence shell. So they can have multiple oxidation states, multiple numbers. Y'all don't have to know these, but when they're given to you, you have to be told their charge in their name. Okay. All right, these ones you get to memorize. Yay! These are the polyatomic ions. So up to now we've been looking at monatomic ions, right? Calcium is one element, can form an ion. Here we've got a group of elements forming polyatomic ions. And y'all are going to have a quiz over this on Friday. All right, so how do we form compounds? Well, we look up their charges and we crisscross. So magnesium has a +2 charge. Fluorine has a negative charge, so this 2 will come down here. This 1, we don't always write the 1, like in algebra, comes down here. So Mg1, which we don't have to write, F2. Here we have this 1 that will come down here. This will come down here, so K3P. Aluminum has a +3 charge, it will come down here. Oxygen will come down here. Okay. All right, when you're naming ionic compounds, you write the name of the cation first, which is the name of your metal. So if we're going to do this compound, we have iron. Then you're going to write the name of the anion and add IDE to the ending. Oxide. If the cation has multiple oxidation numbers, which means it's a transition metal, you have to put the charge in the Roman numerals after the parentheses. So this is iron 3. How did I know it was iron 3? Well, remember when we crisscrossed? Where did this 3 come from? It came from up here, right? And this 2 came from oxygen. So you kind of have to go backwards a little. All right, so let's practice. So lithium and sulfur. Lithium has a +1 charge. Sulfur has a -2 charge. So when you crisscross, you get Li2S. Copper 2, remember this tells you the charge. So copper has a +2 charge. Chlorine has a -1 charge. So when you crisscross, you get copper chloride. Oh, we're supposed to write the name. This is lithium sulfide. I don't have to put the Roman numerals because lithium's not a transition metal. Copper, however, is, so I have to put the 2 in parentheses, chloride. Okay, calcium and phosphorus, crisscross, oops, that's a 3. Calcium phosphide. Okay, zinc, whoops, zinc, and acetate. Acetate is not on the periodic table. That means it's a polyatomic ion. It's on that list that y'all are supposed to know. So this one will come down here. The one for the acetate will come over here. So this is zinc acetate. All right, covalent bonds. They're held together by sharing electrons. So they're between two nonmetals, right? Ionic bonds are between metal and nonmetal. Covalent bonds are between two nonmetals. All right, so your polarity. A nonpolar covalent bond means they share them equally, and these are going to be all your diatomics. Polar covalent bonds are going to be shared unequally, meaning one element is going to kind of hog the electrons. Do you remember when we said we had the electronegativity trend on the periodic table, kind of goes up and to the right? We'll talk more about this when we look at shapes in the next unit. All right, naming covalent compounds. So with covalent compounds, we use prefixes to indicate how many of them there are. So you need to make sure that you memorize these prefixes and subscripts right here. So if we're going to name this compound here, we have 2 nitrogen, so dinitrogen, 3 chlorine, trichloride. Now the only exception is that you're not going to use mono with the first element. All right, so let's practice. We have 2 nitrogen, dinitrogen, we have 1 oxygen, monoxide. Here we have 1 nitrogen, but I'm not going to say mono, I'm just going to say nitrogen, dioxide. 2 chlorine, so dichlorine. 7 oxygen, so heptoxide. Okay, and so in writing them, you look at the prefixes. Iodine, we have 4. No, oxide, that means we've got 9 of those guys. Sulfur, just 1. Hexafluoride, 6. Nitrogen trioxide, NO3. All right, y'all try these. We'll check them in class.